Hello, this is Christian Perring, and this is going to be a presentation on the pre-Socratics. So we're going to cover these Greek philosophers slash scientists and talk about how they try to kind of find rational explanations for what happens in the world rather than just saying, oh, the gods are doing it. We'll look at a whole bunch of them and look at how they were influential on subsequent philosophers. They were around the time of 600 BCE, up for about 200 years. We don't necessarily have exact dates, and also um, there's some debate about who counts, but they were around that time. Uh, We call them the pre-Socratics because they came up to the time of Socrates, and we think of Socrates as a major philosopher. Maybe it'd be sort of more accurate to say they were pre-Platonic, but that's not the label that we use. Uh, Certainly, they influenced Plato probably more than they influenced Socrates. All of them have a kind of basic theory that the world has one sort of fundamental principle or origin or substance known as arche in Greek. And so the idea is there's some fundamental way to explain the whole world. Uh, they weren't, we say whether they were philosophers or scientists is sort of a moot question because there wasn't such a distinction back then. Certainly, they tried to give a different form of explanation from the old Greek myths, but they also didn't necessarily eliminate supernatural. In some ways, the distinction between natural and supernatural wasn't really very clear, but uh, from our point of view, some of their ideas seem pretty supernatural. So, what was distinctive about their views? They were sort of scientific. Uh, they were also maybe debating each other in a sort of rational way. So you have some kind of dialogue, not necessarily all being in the same room, but uh, they probably knew about each other's ideas and they were reacting to their ideas. And so they were, as a group, uh, creating a new way of thinking about the world. So the first person we're going to look at is Thales, uh, and we're going to be looking at three people who lived in Miletus. There's going to be Thales, and then Anaximander, and then Anaximenes. They all knew each other, and uh, they were certainly reacting uh, among each other. Thales was the first, and he was the teacher of the others. He had a reputation as being maybe a bit ahead in the clouds, but he was also very able to navigate the world, and he seemed to be very kind of smart. He studied astronomy. Uh, but the Babylonians and Egyptians also studied astronomy. But Thales was probably the first in the Greek world to really do systematic studies. And he was able to make a prediction about an eclipse in 585 BCE, which impressed a lot of people. Uh, exactly how he did that is lost to time. And it's a bit puzzling because it's hard to know how you would have had enough information. He's credited as dividing up the year into 365 days. and also making distinctions between the kind of the four seasons. I mean, obviously, people have some idea of changes in the seasons, but he did it more mathematically. And he seems to have, been thinking about like the longest day of the year and the shortest day of the year, and then the equinoxes when times of daylight and night are equal. He used mathematical methods to be able to measure the height of large objects like the Great Pyramid of Giza, and he was using shadows for that. So, he's quite scientific from our point of view. He also had a kind of theory that the Earth is floating on water. Uh, and maybe that was relevant to his main doctrine that he thought that water is the principle of all things. He made a bunch of money by making predictions about the weather, and he was able to kind of predict there was going to be a good olive harvest, and he invested in the olive business and made a bunch of money. Uh, so he thought that somebody who was kind of smart, uh, like a scientist like himself, would be able to be very rich, but really what he was interested in was understanding the world. His main doctrine is that everything is made of water, or the principle of everything is water. And certainly that makes sense from the point of view that water is very important in life. But it goes a bit further than that in saying that water is not just important, but actually water is the main nature of the world. Exactly what that means is pretty mysterious. Certainly, we know that water comes in different forms, but our senses tell us that not everything is made of water. So he has this theory that reality is composed of only one thing, or there's some fundamental principle which governing everything, and that's all to do with water. And so his theory certainly goes beyond what the senses tell us. So he's making a distinction between how we know things, and he thinks that the senses lead us into a kind of error. Obviously, he uses senses for some things. And he was able to make predictions about the weather and eclipses and so on. So it's not like he's completely ignoring his senses, but he thinks that to know true reality, you have to use your intellect, not just your senses. So he thinks that appearances can lead us into error, and reality has to be known in a different way. And that was a fairly new way of thinking. It's not totally new in that everybody knows there's illusions and sometimes our senses mislead us, uh, but he wants to kind of take that kind of idea even further. Um, Whether or not he's the first person to come up with a big theory like that is not really certain. Uh, we should definitely not say that Thales was the first person to ever come up with these sorts of theories, but he is the one who gets credited with it. And so that's one of the reasons why his name is so important. He had a student, Anaximander, who was also uh, quite technical and able and scientific. He invented a device called the gnomon, and that was able to actually sort of measure the solstices and equinoxes during the year. So, again, also somewhat useful for prediction. It was based on using shadows, maybe some kind of sundial, and it was pretty important for making for plans when you're trying to work out what the calendar is going to be like. He's also credited with making one of the first maps of the world. He had a different theory about the nature of the world from Thales, uh, and he's often known as saying that everything is primarily the boundless. Now, the boundless or the unlimited is not very clear. Who knows exactly what it is? In some ways, one of the main points is that it's beyond regular understanding. So he's saying, well, there is one sort of fundamental kind of thing. It's like the infinite. Well, that's a little like saying everything is God. Everything is some kind of infinite thing. It's whether that's a naturalistic or a supernatural explanation seems somewhat up for debate. But it is a kind of theory, and he had some kind of idea that he could explain everything with this basic theory. So he thinks the boundless is the original material of existing things, and the source from which existing things derive their existence is also that to which they return at their destruction. Uh, so he wants to say the boundless is not air or water, and so it's none of the elements, but the elements somehow come from this primordial substance. Uh, so there are some kind of ideas or some kind of laws of science that govern the world, something to do with uh, how opposites interact. He's interested in hot and cold and wet and dry, but he also has some kind of idea of justice as a something that governs the world. That's a bit more mysterious. This idea, the Hyperion or the boundless, uh, is completely central to his view. And its idea that though everything derives from it, so in some ways a kind of view of evolution, the explanation of everything. And he thinks that goes to explain the nature of humans. He thinks that somehow humans derived from some kind of animals that came from the sea. And so that seems very speculative, but also uh, makes us think about Darwin, who said that all life eventually originally came from the sea. So it's a surprising connection there. He had a particular theory about the nature of the Earth. He didn't think that the Earth was resting on water, because then he asked, well, what would the water be resting on? So he thinks that the Earth is actually a flat cylindrical disk floating in the center of the cosmos. Now, the first question is going to be, well, why doesn't that fall down? And he says that, uh, well, that's the nature of the boundless, and somehow this disk just stays in place. And we get to Anaximenes, we're just going to mention briefly. He disagrees both with Thales and Anaximander, and he says that the fundamental principle of the universe is air. That's why that's a more plausible view than everything is water or everything is the boundless is a bit mysterious. He has some ideas about the elements coming from condensation and rarefication, but We don't really know why he thinks his view is more plausible. So just a brief mention of Anaximenes. Moving on, we get to Pythagoras. Pythagoras is certainly a big name. Uh, he's known for the Pythagorean theorem. Uh, Whether he was the first person to really come up with this, again, is a little bit speculative, but certainly, we believe that this view that a squared plus b squared equals c squared for a right-angled triangle was created by Pythagoras or his group of followers. There's certainly a group of philosophers known as the Pythagoreans who kind of investigated these ideas and also had a certain lifestyle. And we know that they thought it was important to be considerate to other creatures, and they were known as being vegetarians. Pythagoras especially thinks mathematics is a sort of central principle behind everything, and that's definitely an interesting view because we see that kind of idea in modern physics too. So it seems like Pythagoras is anticipating the approach of modern physics, uh, in that everything is ultimately explainable in mathematical ways. He's also known for the view that the soul, whatever it is that makes us kind of who we are, is not a physical thing, but rather a non-physical thing, and that it's eternal. He also thinks that all animals have souls, and so that's part of the reason why we should be considerate to other animals. He has this idea, his idea of mathematics is especially to do with kind of geometry, and he was very interested in the tetractys, the equilateral triangular figure consisting of 10 points arranged in 4 rows. Now, I've talked about how there's kind of questions about what's natural or supernatural. I mean, so people who think that numbers rule the universe, in some ways that seems somewhat supernatural. People who think that 13 is an unlucky number, that seems to kind of like a superstition. So this idea of placing importance in numbers uh, and thinking that numbers somehow rule the universe seems a little going beyond natural science from our point of view. Pythagoras definitely thinks that ratios and numbers are extremely important in determining the universe, and so that's partly illustrated in his idea of this equilateral triangle. But it's also there in his ideas about music, and he thinks that music is essentially a sort of a mathematical discipline, and that different kind of uh, notes and instruments should be understood mathematically. So he talks about the fourth and the fifth and the octave as mathematical. But his larger point is that this is to do with the harmony of the spheres. And again, he still goes way beyond our experience by saying that the celestial bodies have some kind of harmony and celestial music kind of going on in some ways, even though we can't hear it. So that's very speculative. But maybe the kind of thing that's especially interesting with Pythagoras is he thinks that the universe has a kind of well-ordered structure, which is beautiful. And he thinks that this structure is based on numerical ratios. So for Pythagoras, he has this idea that numbers are essential to the nature of the universe, and um, That's a very distinctive idea. There is a story about him seeing a person beating a dog and saying that it sounds like his friend, which is somewhat puzzling because generally we don't think that animals being beaten sound like any people, but that's what the story is. And it's sort of further illustrating this idea that he doesn't think we should beat dogs because dogs have souls. Moving on, we get to Heraclitus. Heraclitus has the view that everything is constantly changing. This gets summarized by the phrase, you can't step in the same river twice. And that's easy to understand because the water is flowing through the river. It's not a stagnant pond, so it's constantly different water. But Heraclitus is saying that everything is constantly changing. So this means that he thinks that despite appearances, even things which look the same are in fact constantly changing. So that's definitely going beyond appearances and saying the reality behind that is different. And again, it's he doesn't think that change is chaotic. The world it behaves in a well-ordered fashion, so there's something kind of keeping all the changes in place and making things look like they're very orderly. And in fact, they are very orderly on his view. So he has this idea of constant change or flux, and he kind of talks about this in terms of everything always becoming rather than being. We'll see the contrast in a second with Parmenides, who says everything just is and is never becoming. So these two philosophers get uh, contrasted with each other because their views are so dramatically opposite to each other. Heraclitus introduces an idea of a rational principle governing everything, which is kind of like laws of science, but it seems to go a bit beyond that. We've seen with other pre-Socratics, they think that we can explain the world through these kind of principles. You had Pythagoras talking about the harmony of the world. Heraclitus talks about logos, which we might think of as some kind of ultimate logic governing the world. So it's some kind of, but it's like a cosmic force. I guess in some ways the laws of science as we think of them now are some kinds of cosmic force too. But there's a fundamental idea that the world is rational, is reasonable in some way. And so that to truly understand the world, we need to understand this logos. And again, it goes a little supernatural in that we think of it as a kind of, maybe even a kind of divine intelligence. So here's Parmenides. Uh, and as I said, he says that nothing ever changes, everything is permanent. Nothing ever becomes. So he thinks that change is an illusion. He thinks that since nothing ever changes, then everything has always been as it is, and is always going to be as it is. Uh, while Heraclitus's view seems like, oh, we can sort of understand that, and you can see how things that look the same may be changing, even though they doesn't look like they're changing. With Parmenides, it's a bit more mysterious because how can everything's look like they're changing if nothing is ever changing? That seems to be harder to explain. But that was his view. So Parmenides seems to be one of the most dramatic deniers of common sense. He thinks that nothing changes, everything is permanent. And that definitely contradicts everything we think about the world. So clearly he has to depend on this distinction between appearance and reality and say that reality is very, very different from how it appears. And all the appearances of changes are just some kind of illusion. He has a kind of argument for his view. He thinks that it's just basically impossible to really understand change as being possible. Uh, Now, from our point of view, this argument has to be just a mistake. Change is possible. So he's placing a lot of confidence in his argument that change is impossible. Uh, and we might think, well, that's a sort of misguided confidence. Uh, but he definitely kind of held this view, and it was somewhat influential. One of the people who tried to defend Parmenides was Zeno of Elea, and he came up with arguments which make a little bit more sense, although we're going to show how, in fact, he was just mistaken. And But he thinks that his paradoxes are able to support the views of Parmenides. One of his paradoxes is known as Achilles and the tortoise, which argues that it's impossible for Achilles to ever catch up with the tortoise. Uh, all his arguments basically are pretty similar in their form, and it's more straightforward to understand the dichotomy paradox. The dichotomy paradox says motion is impossible because for motion to happen, an object would have to go through an infinite number of points, and that would take an infinite amount of time. But uh, that just actually doesn't make any sense. And now we can prove it doesn't make any sense because we have modern math, we have a theory of limits, which is a sort of the precursor to calculus. And we know that you can sum a sequence of a half plus a quarter plus an eighth plus a 16th, and that is going to sum to one. It's not going to sum to an infinite sum. And that means that, yeah, it's true that for motion to be possible, you have to go through an infinite amount of points, but that doesn't have to take an infinite amount of time. You can do it in a finite amount of time. And so we could have a perfectly good understanding of the nature of change. Uh, so it definitely kind of, you see this part of rationalism. Rationalism is the idea that our senses lead us to error and we should understand true reality through our intellect. Uh, and it really exemplifies how rationalism is a pretty risky approach because you can place far too much confidence in our ability to rationally prove anything uh, just from first principles, while our senses may be a pretty good guide to how to understand the world. So the failure of Parmenides and Zeno is a pretty good lesson for being suspicious of rationalism. Finally, we're going to look at Democritus, who seems in some ways pretty sensible in his theory. He definitely kind of says that the world is made of something we can't see, but those are atoms on his view. He thinks the world is made of atoms, tiny objects, which are unchanging, and they're in different shapes and sizes, and they move around in regular ways. And those regular ways are governed by kind of laws of science. And he thinks that all the things that other people would explain through earth, water, air, and fire can really be explained by atoms, atoms moving in the void. And that fits very well with our kind of current views, or at least very well with views maybe more linked to the 16th and 17th century. Modern physics is a bit more complicated, I would say. But we can certainly understand the atomistic view pretty intuitively. On the other hand, we might ask, well, does he actually have any reason to believe there are atoms? Certainly, this is a big speculation, a big hypothesis, and it's not clear he can present any evidence for it. What is interesting is that Democritus's view uh, seems to rely on natural laws governing the objects of the universe. And in some ways, his view of natural laws seems a bit closer to our view of natural laws, in that they're not like some kind of divine creation. Rather, they're just a feature of the universe, that everything has to move around according to these laws. So that's all the pre-Socratics we're going to look at. Here's a summary of them in terms of their school and the fundamental principle that they defended. And finally, I want to kind of emphasize this idea that the pre-Socratics were very interesting with all their theories. But one question we might have is like, well, what made them so sure of all their theories? They had these kind of fancy arguments for them, but those arguments don't seem to really be very impressive. And it seems like really they might have been better off just saying, well, here's an idea, but I don't know what the truth is. So it leaves us wondering, why were they so confident about their claims when they couldn't really present any strong arguments for them? All right, that's it.